with regards to controlling water pH, most of our irrigated lands are in California are wells, and those wells tend to be high TDS or high total dissolved salts, and they're high in bicarbonate. And those bicarbonates are what elevates the water pH, and it locks up particularly calcium and magnesium in the sense of being plant available. So most water, well water, has a tremendous amount of calcium and magnesium. It could have other constituents as well, but there's some, it's free fertilizer in essence when it comes to cal and mag. So the reason to acidify is utilizing an acid of some sort to dissolve the bicarbonate that is attached to calcium and magnesium. And this is a solubilization reaction where it allows calcium, magnesium to be more soluble in water. It allows it to be more plant available. That's in a available form versus, say, a calcium carbonate, which is not a plant available form. And that's in most cases, sulfuric acid is the dominant acid that's used. So carbonic acid, it works very similar to lowering the pH or buffering the pH down in the water as sulfuric. It's solubilizing that bicarbonate off by exchanging it with hydrogen, right? And that bicarbonate then turns in primarily water and CO2, right? And that it frees up the calcium and magnesium in the water. And it also, the other salts that are in the water as well. And so in the sense of one-to-one comparison, carbonic acid does exactly the same thing that sulfuric acid does, but some of the disadvantages to sulfuric acid is one, it's a big hazardous material in the sense of personal safety, the sense of equipment failure and damage, because it is a strong acid. It's a really strong acid compared to, say, carbonic or even citric acid, right? And so you have the tendency of burning holes in underground irrigation lines, corroding or burning holes through any of your steel manifolds that are above ground, your filter tanks as well, if they're injecting upstream of the filters. And so that there's some hazards there that a lot of growers they've dealt with over the years, but now with carbonic acid, being it's not a corrosive acid, it could be injected into mild steel, stainless steel, PVC, and not have any type of detriment to the system. It's in the sense of safety, it's a much better product. It's not a hazmat product in the sense that you have personal safety if you're exposed to that CO2, and the carbonic acid if it's for whatever reason you have a break in the line. And so in that sense it's very similar, but sulfuric acid is a much dangerous product to utilize. Once we start getting into the additional benefits that you gain from carbonic acid, this is where I think there's a huge amount of value for growers, both agronomically, production, cost savings. There's a number of things that agronomically that carbonic acid provides that we don't see that with a lot of the other acids. In fact, you don't see it at all, because carbonic acid is a carbon-based molecule. You have a lot of benefits. One is you no longer have a salt-based acid in your system. So typically we see a lot of high ECs in soils due to the amount of sulfate that is in, or sulfur that's in sulfuric acid. Same with the sulfur burners, right? So when you eliminate and a salt out of the system, you tend to see where ECs of the soil start to kind of stabilize and lower, and you're not contributing to the overall salt load within the soil. The other aspect is that carbon is now one of the byproducts. You're contributing carbon to the soil. And so that plays a role in the microbial activity within the soil. It's a food source, right? So for microbes, carbon and nitrogen is the two main food sources that they have to consume in order to run their processes. So that could be in the sense of decomposition of, post or previous crop residue. And that also helps nutrient cycles that are in the soil. And that goes for all elements, right? So nitrogen, phosphorus, also, potassium, calcium, magnesium, all your minor elements. And so there's this nutrient cycle for each one of those.